Hi everyone. So what I'm going to do is a quick little follow-up on 3 topics that people asked about, combinations and permutations, theoretical probability, and two-way tables. Some other questions people asked is, no, I'm not going to put this quiz in a lockdown browser just to avoid any potential tech issues, and I'll link the Desmo Scientific Calculator that you can open that up in another tab to use that during the quiz. Okay, so let's look at our 3 topics. Now, if there are any other topics that come up, just email me or put in discussions, and we can always do a quick Zoom or Google Meet before you take the quiz. So the first one was combination versus permutation. So remember that a combination is a group of objects in which the order doesn't matter. So the order does not matter when we're talking about a combination. Whereas a permutation is that arrangement or lineup of objects in which the order does matter. So order matters for a permutation, order does not matter for a combination. So let's try some practice problems. So in practice problem number 1, there are 20 employees at Subway. How many ways can the manager choose 5 for the Sunday evening shift? So in practice problem number 1, this is going to be a combination because the order doesn't matter. So our setup is going to be 20 combination 5, and then I plug that right in my calculator, and I got 15,504. In problem number 2, 7 students are competing in a spelling bee. How many ways can they finish in first, second, and third place? So here, order is going to matter. So it's going to be a permutation. So it's going to be 7 permutation 3. And I typed that right in my calculator, and I got 210 different ways. So I'm going to have you try 3 and 4, and then we'll kind of just check them. So let's look at 3. There are 28 students in Mr. Miller's homeroom. How many ways can the students elect a student council representative and then an alternate? So permutation, because order is going to matter. So it's going to be 28 permutation 2, and there's going to be 756 different ways they can elect those 2 people. In problem number 4, try that one, and then we'll check it. So in problem number 4, how many ways can you choose 3 books from a shelf of 25? So order does not matter. So we're looking at 25 combination 3, which is going to give me 2,300. So topic number 1, permutation versus combination. Hopefully that cleared up anything we might have. In topic number 2, theoretical probability. That's just the probability is the measure of how likely something is to occur. So the likelihood of something to occur. If we look at this first example, a jar contains 26 red marbles and 18 blue marbles. What is the probability that a randomly selected marble is blue? So add up 26 and 18, and that gets me 44. What's the probability of getting a blue marble? Well, that's 18 over 44, and we always want to put it in simplest form, so 9 over 22. And in this last problem, try it on our own. What is the probability of drawing a 9 or a diamond from a standard deck of cards? So we know that there's 52 cards in a deck. There's diamond make up 4, or you can even do 52, divide that by 4, the 4 differences, that's 13. And then there's 3 other 9s accounted for, so that gets you 16 over 52. Put that in simplest form, and that's 4 over 13. So once again, we got the 16 because there's 13 diamond cards. That includes the 9. So there has to be 3 other diamond cards. 3 other 9s, sorry. So that gives me 16 over 52. Any questions there? Please let me know. And on our last topic, here we're looking at our two-way tables. So here we have, if you have a table shows the number of students that do or do not have their own car and whether they have part-time jobs or not. So we are given this table. The first thing I did was fill it in the totals just to kind of do that in the beginning. So 96 have cars, 54 don't have cars, 108 have part-time jobs, 42 don't have part-time jobs. A total of 150 people were surveyed. So in part A, what's the probability that a student with a part-time job without a car? So here, we're not looking at that given situation that we were doing before. So it's just how many students with a part-time job, without a car. So no car, part-time job, that's 30 over that entire 150. That's no given. So that reduces down to 1/5. In B, what's the probability that they don't have a car given that they have that part-time job? So here, almost think that what we're setting this up as is we're setting this up as the overlap over the no job. So what we see here is where the overlap of no car and does not have a part-time job, that's that 24, over how many people do not have a part-time job, well, that would be 42. So we're looking at 24 over 42, which gets me 4 over 7. So look at the overlap between no car and no part-time job, and then think of this as the second part of that sentence is going to be my denominator. So in part C, what is the probability of a part-time job given they have a car? So once again, we're doing that same setup. What's the overlap of those two statements? What's the overlap over they have a car? So here what we're looking at is the overlap of they have a part-time job and they have a car. So that's 78. And then how many people have a car? That's 96. So 78 over 96, which simplifies down to 13 over 16. So hopefully this helped. If there's any follow-up questions, please ask.